All right, so today we're going to talk about graphing quadratic functions. Yesterday we talked about how the standard form of a quadratic function is ax squared plus bx plus c. So now we're going to use that to graph quadratic functions. I don't know why the animations are going so fast. I will go all over this one more time, so don't worry. You will have time to write this down. I'm going to ask Miss Quinn to pause the video. You do need to write all of this stuff on the left. So quadratic functions, the graph of a quadratic function is a parabola. A parabola can open up or down. If the parabola opens up, the lowest point is called the vertex. And if the parabola opens down, the vertex is the highest point. Note, if the parabola is open left or right, it would not be a function. Actually, tell a lie, you don't need to write this part down. We already wrote that down yesterday. So our vertex is down here. It's basically the point in which the curve turns, and then our vertex would be here if the parabola opened down. So this one opens up, this one opens down. If the parabola opens upwards, we have a minimum value because that's the lowest point. If it opens downwards, we have a maximum value because that's the highest point. All right, standard form, we talked about it yesterday. Y equals ax squared plus bx plus c. We put 0 here yesterday, but we can have y. Standard form of the quadratic, the parabola opens up, the a value is positive. Look at that. If it opens down, the a value is negative. Again, we talked about all of this yesterday. All right, line of symmetry. This is what's new, so this time you will have to write down your notes. Parabolas have a symmetric property to them. Just like back in 3rd and 4th grade when you were talking about rectangles and drawing lines of symmetry on them, parabolas have one as well. If we drew a line in the middle of the parabola, we basically fold it in half. Here it is, 2 sides. So we call this line the line of symmetry. Or if we graphed one side of the parabola, we could fold or reflect it over the line of symmetry to graph the other side. I want these last 2 bullet points written down. We call the line of symmetry the bit that goes through the parabola, or if we graphed one side of the parabola, we could fold or reflect it over the line of symmetry to graph the other side. Look, there's an example. I graphed one side, I fold it over or reflect it, there's the other side. The line of symmetry always passes through the vertex. Always, always, always. Please make sure you know that. The line of symmetry is always going to go through the vertex. So finding the line of symmetry, there is a formula for finding it when the quadratic is in standard form. We said standard form is y equals ax squared plus bx plus c. So the formula to find the equation of the line of symmetry, and if I go back here, we see that the line of symmetry for a parabola is a vertical line. Remember, vertical lines have an undefined slope. They pass through an x value, so the equation of vertical lines are always x equals whatever the x value is. So we're going to find that x value to write the equation of this line. To find the line of symmetry, we're going to use this formula. X is equal to negative b over 2a. So basically, the way we're going to read this is it's the opposite of b. Remember, b is the coefficient of just x to the power of 1, over 2 times a, which is negative b divided by 2a, or the opposite of b, divided by 2a. All right, here's an example. We have this in standard form. A is 3 because a is the coefficient with the x squared. B is negative 18, negative 18x, and then plus 7, that's our c. Remember, you can rewrite all subtraction as adding a negative, so if you struggle to see that this is really negative 18x, I would just go ahead from the start and change this subtraction to plus negative 18, and then it'll be real easy to see that. So we're going to use the formula. X is equal to the opposite of b, or negative b, divided by 2 times a. So I got my negative 18. Well, what's the opposite of negative 18? That's positive 18. And then our a value is 3, 2 times 3. We see that the opposite of negative 18 is positive 18. We have 2 times a, and a in this case is 3. Well, 2 times 3 is 6, so 18 divided by 6 is 3. So the line of symmetry is at x equals 3. Remember, the equations for these lines are vertical lines, so it's x equals whatever the x value is. Now to find the vertex, we already talked about how the vertex, the line of symmetry passes through it. So when I find the equation of the line of symmetry, I've basically got the x-coordinate of the vertex. Make sure you write these down. The x-coordinate of the vertex, because that line of symmetry is a vertical line, I have the x-coordinate when I use my formula. Then after I have the x-coordinate, I can just go back to the original equation in standard form and solve for the y-coordinate. So in this case, we have y is equal to negative 2x squared plus 8x minus 3. First things first, I'm going to solve for the line of symmetry so I can get my x-coordinate of the vertex. So to do that, I have x is equal to the opposite of b divided by 2 times a. Well, b in this case was positive 8x, the opposite of, or positive 8. The opposite of 8 is negative 8. A in this case was negative 2. I have 2 times negative 2. Well, 2 times negative 2 is negative 4. Negative 8 divided by negative 4. A negative divided by a negative is a positive. So the equation of the axis of symmetry is x equals 2. Well, that is my x value. So I'm going to go back to my original equation and plug in to find the y value. So we have negative 2 times 2 squared, because I plugged in 2 for x, plus 8 times 2, again plugging in 2 for x, minus 3. Well, 2 squared is 4. Negative 2 times 4, I get negative 2 times 4 is negative 8. Plus 8 times 2, well, that's 16 plus negative 8, so we're back to 8. Minus 3 is 5. We just see I multiplied and added those. So the coordinate of our vertex is 2, 5, because I already found the x value with the line of symmetry, plugged in, solve for y, the y value is 5. Remember, your vertex is always on the line of symmetry. The line of symmetry passes through the vertex. Okay, quadratic functions in standard form. The standard form of a quadratic function is given by y equals ax squared plus bx plus c. There are 3 steps to graphing a parabola in standard form. Step number 1, find the line of symmetry. Remember, we find the line of symmetry by saying x is equal to the opposite of b divided by 2 times a. And then we're going to find the vertex. Well, we're going to use that line of symmetry equation, find the x value, then plug in for y. And the last step is to find 2 other points and reflect them across the line of symmetry, and then connect the 5 points with a smooth curve. So when we were talking about linear functions, I made you graph 3 points on a line. Quadratic functions, you will have to graph 5. To do this, you're going to make a table and using the x values close to the line of symmetry. So like if the line of symmetry was at 3, I would pick the x values of maybe 2 and 4. Here's an example of this. Y equals 2x squared minus 4x minus 1. This is in standard form. Our a value is 2. Our b value is negative 4. C is negative 1. First things first, find the line of symmetry. Well, x is equal to the opposite of b over 2 times a. The opposite of negative 4 is positive 4. The a value is 2. 2 times 2 is 4. 4 divided by 4 is 1. So our axis of symmetry is at x equals 1. Now, to find the y value, I'm just going to plug in 1 for y, or 1 for x. To find the vertex, since the x value of the vertex is given by the line of symmetry, we just need to plug in x equals 1 to find the y value. Well, we have 2 times 1 squared minus 4 times 1 minus 1. 1 squared is 1. 2 times 1 is 2. 4 times 1 is 4. 2 minus 4 is negative 2. Minus 1 is negative 3. So our vertex is at 1, negative 3. Put a point. Now to get our 2 other points that we're going to reflect over, I'm going to make a table. We see that the x axis is at 2. So, or the the line of symmetry is at x equals 1. A close value to that would be 2. Another close value to that would be 3. So I'm going to plug in these 2 numbers for x. Well, if I go in here, 2 squared is 4, times 2 is 8, minus 4 times 2, minus 4 times 2, so that's 8 as well. 8 minus 8 goes away. I'm at negative 1. Then if I plug in 3 here, after I plot that point, 3 squared is 9, 2 times 9 is 18, minus 4 times 9, well, 4 times 9 is negative 36. Oh, excuse me. Not 4 times 9, 4 times 3. We're plugging in 3 for x. So let me go through that one again. X squared is 3 squared is 9, times 2 is 18, minus 4 times 3. Well, 4 times 3 is 12. 18 minus 12 is 6, minus 1 more is 5. So we have 3, 5. Now I'm just going to reflect these 2 extra points across the or the line of symmetry. So this one is 1 space away. So I'm going to come over here and move 1 space away. And then this one was 2 spaces away, move 2 spaces away. Now I can put a curve through all of them, and I now have a quadratic function in standard form. What is the axis of symmetry? Well, the axis of symmetry was the line that went through it, so our axis of symmetry is x equals 1. What is the vertex? Our vertex here is at this point in the curve. Well, I go over 1 and down 1, 2, 3, so 1, negative 3. What are the x-intercepts? This one will be a little bit trickier. We'll start talking about that in maybe next week. And their x-intercepts are where we cross the x-axis. So I can see it's just past 2 and it's just past 0 here are going to be our x-intercepts. You'll find pretty soon that our zeros are just our x-intercepts. And then what is the y-intercept? Well, that's where it crosses the y-axis. It crosses the y-axis at 0, negative 1. What's the range and what is the domain? So the domain, as I see this line, it's going to go up forever to the right because it's going to keep going to the right forever. That's all of the numbers that are positive. It keeps going to the left forever, so that's all the numbers that are negative. So it's all real numbers to begin with. The range, well, I can't go below this minimum point, but everything above it is fair game for a y value. And since the line goes through the minimum point, I'm going to say y is greater than or equal to negative 3 for the range. All right, standard form is f of x is equal to ax squared plus bx plus c. That's what we've been talking about. Vertex form is a times x minus h squared plus k, where h and k are part of our vertex. We'll talk about that next week. And then factored form is a times x minus m times x minus p. Again, we're going to talk about that next week. The shape of the quadratic function is a parabola. If it faces upwards when I plot the points, this means our a value is greater than 1. Faces downwards, our a value, or not greater than 1, greater than 0. This faces downwards, our a value is less than 0. Okay, parabolas are symmetric about the central line. We talked about that line of symmetry called the axis of symmetry or the line of symmetry. It cuts the parabola in half vertically through the equation of the form x equals whatever the x value is. So in this case, our axis of symmetry or line of symmetry is at 0, x equals 0. And we use this formula, opposite of b divided by 2a, to get that. This one, it cuts through the graph at negative 2, so x equals negative 2. And this one cuts through the graph at 3, x equals 3. So the axis of symmetry intersects the parabola at only one point, the vertex. The maximum vertex is the highest point, minimum is the lowest point. The vertex is where the range of values begin. It's listed as y is less than or equal to the number. So if it's a maximum, it's less than or equal to. If it's a minimum, y is greater than or equal to. So for this particular graph here, we see that the line of symmetry goes through the vertex at 0. So our equation is x equals 0. Our vertex is this point on the curve, so it's 0, 2. The minimum is also our vertex in this situation. It is a minimum because this is the lowest point. Everything else is above it. Like I talked about before, this graph is going to go forever to the right. It's also going to go forever to the left, so the domain is all reals. The range, however, everything above the minimum is a valid number, but nothing below it will work. So we're going to say y is greater than or equal to 2. Let's continue to practice this. What's the axis of symmetry or line of symmetry for this one? Well, it goes through at x equals negative 2. The vertex is at negative 2, 0. It is a maximum this time because this is the highest point on the graph. Again, the domain, this is going to go forever to the right. This will go forever to the left, so it's all reals. The range, it goes all the way up until it touches this 0, and then it does not go any further. So y is less than or equal to 0. The axis of symmetry for this one is x equals 2. The vertex is at 2, 1, 2, 3, 4, so 2, negative 4. It is a minimum because this is the lowest point. Everything else above it will be included. The domain still, we go all to the right, all to the left. It's all reals, and it's everything greater than -4. All right, ladies and gentlemen, your homework for tonight is 4.3, I believe. Yes, 4.3.